never mind. Let's continue. So this is the first two-tailed test. If I want to test whether whether this coefficient is significant or not, so it's definitely a two-tailed test. We use a two-tailed test. We find the alpha divided by 2 at one tail, and the two tail, we add all that up, we got alpha, and that is the one tail test. That's a two tail test. But now we are going to talk about the one tail test. So what is the one tail test? So normally I'm just going to test whether this coefficient is significant or not. But if I want to test something like this, you will need to use the one-tail test. Say that if a portfolio manager, that manager a portfolio, and I want to know whether this portfolio manager's skill is so good that he always outperformed the S&P. You know, S&P is just an index. So I want to know whether he's always outperform S&P by 10%. Okay, so it's more than S&P by 10%. Okay, if you want to test that, you have to use the one-tail test. Okay, so as the old rule, we need to use the null hypothesis and alternative hypothesis. You kind of need to put all the things that you want to validate, all the things you want to know that is true. You want to test whether it's true or not. So you put that at the alternative hypothesis, and you reject the other part. You reject the non-hypothesis, and there naturally comes to the conclusion that you have to kind of accept the alternative hypothesis. And actually, the alternative hypothesis is just a conclusion that I want to prove. Okay, that's the workflow. So let's just continue. So the non-hypothesis will be say that the B1, if I'm working at the B1 here, the alternative hypothesis is B1 minus 10%, and B1 alternative hypothesis to B1 bigger and equal to 10%. All right. And of course, since it's one-tail test, the tail that we want to analyze is just as same as the alternative hypothesis. So the alternative hypothesis is the bigger than 10%, so it's the right tail test. So it's here. This is a rejection area, and this is a critical line here, and this is a non-rejection area. All right. So let's just use the calculation here. So I can use the B1, and of course, since the critical point we are talking about is 10%, so I'm going to subtract 10%. Of course, we're going to divide by the standard deviation of B1. But of course, if there is no standard deviation of B1, what should you do? You should find the original t statistic of B1, so B1 minus 0, and the standard deviation is here. So if you know the original two-tail test of whether B1 is significantly different from 0, you got the t statistics, you got the B1, and you can naturally calculate the S here, and you put S there. And of course, you are going to get a new t statistics. And you can use this t statistics. For example, if you check all this number, you find this is the 2.65. I don't know. I just write a random number here. All right. And the t statistics say that there is 3. All right. So you kind of get into the range of rejection area, which means that you're going to reject the non-hypothesis and kind of accept the alternative hypothesis. So you will know that it's kind of true under certain confidence interval that these portfolio managers, this fund manager, always outperform S&P by 10%. That's the logic behind this one-tail test. Okay, so the few points you need to understand. First is that you always want to put the conclusion that you want to get as the alternative hypothesis, and you reject the other half. And the second is if it is one-tailed test, the tail that you want to think about is always the same side with the alternative hypothesis. Okay,